So next we'll find the ratio of three types of speeds. Okay, average speed, RMS speed and the most probable speed. So we know that average speed is given by C bar, which is root over 8 kt by pi m. RMS speed is capital C, root over 3 kt by m, and the most probable C is capital C suffix m, which is given by root over 2 kt by m. Now to find the ratio, so we take the ratio. So C bar is to C, the RMS speed, is to the most probable speed Cm. Now put their values. So from these three terms kt by m are common, so they will get cancelled out, and we will have from the C bar we will have root over 8 by pi, from C we will have root over 3, and from C we will have root over 2. Now if you calculate their values, root over 8 by pi is up to 3 decimal places is 1.595 is to 1.732 for root 3, and for root 2 we will have 1.414. So smallest one is the 1.414. Okay, so what we will do, we will divide each of these numbers by 1 by 414, the smallest one. Okay, so over here if we divide it by 1.414 we will have 1, and okay, so for the first term we will have 1.595 divided by 1.414, which will give us 1.128, and for the second term dividing it by 1.414 we will get 1.224, and then we have 1. Okay, so this is the ratio of C bar, C and Cm. Now if you want to write them in the ascending order, so we can say that which one is the smallest? 1. So most probable speed is the smallest. Then we have C bar, the average speed. Then we have the root mean square speed, which is the greatest. Okay, so writing it in the ascending order, we'll first have the most probable speed Cm, then the average speed C bar, and then the RMS speed capital C. So in the ascending order, the ratio is 1 is to 1.128 is to 1.224. Now they can be represented in the distribution curve also. So we have that this RMS speed is the greatest, then we have the average speed, then the most probable speed is the smallest. Okay, so this is our distribution curve, F versus C, we already know that, and at the most probable speed Cm we get the peak, F is maximum. Okay, then we have C bar. So C bar will have a greater value than Cm, so C bar will be somewhere over here, and C is the greatest, greater than both C bar and Cm, so C will have greater value somewhere over here. Okay, now another thing is that suppose if we write the expression for the average speed, which is given by root over 8 kt by pi m, where m was mass of a gas molecule, right? Now let us multiply it by Na. Okay, what is Na? Na is Avogadro number. Okay, so mNa will give us mass of Na number of gas molecules. Okay, so if we have Avogadro number of gas molecules, their mass is called m, if it is written as capital M, which is called molecular weight. So mass of Avogadro number of gas molecules is called molecular weight, which is written as capital M. Okay, so now we'll try to represent the three types of speed in terms of molecular weight. So first start with the average speed, which is given by 8 kt by pi m. Now we'll multiply the numerator and denominator inside the root with this Avogadro number. Okay, so k Na into T divided by pi m Na, then the root. Okay, now KNA is R. What is R? R is ideal gas constant. Okay, so you already know this. KNA is R, which is ideal gas constant. So it is 8 RT by pi m. Thus we have a new expression for the average speed, which is root over 8 RT by pi m, which is expressed in terms of the ideal gas constant and the molecular weight of the gas. Okay, then in this way we can express the other two speeds, which are the root mean square speed, C, capital C, it was 3 kT by m, so it will be 3 RT by capital M, root over 3 RT by capital M, and the most probable speed, which was root over 2 kT by small m, now it will be root over 2 RT by capital M.